The National Electrical Code does not specifically address the use of a three-phase panel for a 120/208 single-phase UPS output. However, examining related code sections provides guidance. NEC 220.12 states that single-phase, three-wire circuit shall be connected to a three-wire circuit breaker. NEC 210.5 says that single-phase, 240-volt circuit shall be connected to a three-wire circuit breaker with a neutral bus. These sections suggest that a three-phase panel can be used for a 120/208 single-phase output, provided that the panel is properly configured. This means using a three-wire circuit breaker on the single-phase line and ensuring a neutral bus is present. Now, regarding concerns about using 88 volts on L2, the NEC doesn't explicitly prohibit it, but several factors should be considered. Firstly, there's equipment compatibility. Some equipment may not be rated for operation at 88 volts, potentially leading to damage or malfunction. Secondly, safety hazards arise. If a 120-volt device is accidentally connected to the 88-volt output, it could result in an electrical shock or fire. Thirdly, code violations could occur. If the panel isn't properly labeled or marked as having an 88-volt output on L2, it could be considered a code violation. Because of these concerns, it's generally recommended to use a single-phase panel for a 120/208 single-phase UPS output. This avoids the potential problems associated with having 88 volts on L2. Let's move on to the emergency power off, or EPO, button requirement. NEC 705.32 B1 states that information technology equipment rooms, critical areas, and similar spaces shall have an EPO. An information technology, or IT, room is defined in NEC 645.2 as a space that contains a group of information technology equipment or telecommunications equipment having a maximum electrical power demand in excess of 10 kilowatts and is normally accessible only to authorized personnel. Based on these code requirements, an EPO is required in any room that meets the definition of an IT room. It's also generally a good practice to err on the side of caution and install an EPO in any room that houses critical equipment, such as servers or data storage systems, even if it doesn't strictly meet the IT room definition. To recap, firstly, when using a three-phase panel for a single-phase UPS, ensure it's properly wired with a three-wire breaker and neutral bus. Secondly, carefully consider the implications and potential hazards of an 88-volt output, favoring a single-phase panel when possible. And thirdly, understand the EPO requirements for IT rooms as defined by the NEC and consider erring on the side of caution for critical equipment areas. Remember, always consult the latest edition of the NEC and local amendments for the most accurate and up-to-date information. Also, be sure to consult with a qualified electrical engineer or inspector for specific applications to ensure code compliance and safe installation practices. This information is for educational purposes only and not a substitute for professional electrical advice. Further clarification on each of these points is beneficial. In reference to using a three-phase panel for a single-phase UPS output, it's important to delve deeper into the reasons why this might be considered. Often, it's due to existing infrastructure or future expansion plans. If a facility already has a three-phase panel installed and readily available, it might seem more convenient to utilize it for the UPS output rather than installing a separate single-phase panel. However, this convenience must be weighed against the potential complications and safety concerns. Regarding the wiring of the three-phase panel, it's absolutely crucial to ensure that the single-phase UPS output is connected to a double-pole breaker, utilizing two of the three available phases. The third phase should remain unused and properly capped off to prevent accidental connections. The neutral conductor from the UPS output should be connected to the neutral bus in a panel, and the grounding conductor should be connected to the ground bus. Proper labeling is paramount. The panel must be clearly marked to indicate that it's being used for a single-phase UPS output, and the voltage of each phase must be clearly identified. If L2 has an 88-volt output, this must be explicitly stated on the panel to prevent accidental connections of devices that are not rated for that voltage. Moving on to the concerns about using 88 volts on L2, let's examine these in more detail. As previously mentioned, equipment compatibility is a major factor. Most standard 120 volt equipment is designed to operate within a specific voltage range, typically plus or minus 10%. An 88 volt supply falls significantly outside this range and could cause the equipment to malfunction or even be damaged. Motors, for example, may overheat and burn out if subjected to undervoltage conditions. Electronic devices may experience erratic behavior or failure. Safety hazards are another significant concern. If a 120 volt device is plugged into an 88 volt outlet, it may not operate correctly, but more importantly, it could create a shock hazard. The device may draw excessive current in an attempt to compensate for the undervoltage, which could overload the circuit and potentially cause a fire. Furthermore, if the device is not properly grounded, the undervoltage could create a dangerous potential difference between the device and ground, increasing the risk of electric shock. Code violations can arise if the panel is not properly labeled or if the installation does not comply with other applicable NEC requirements. For example, NEC 110.3b requires that equipment be installed and used in accordance with its listing and labeling. If a device is not rated for operation at 88 volts, connecting it to such a voltage would violate this requirement. Similarly, NEC 408.5 requires that panel boards be clearly and durably marked to indicate the circuit to which each overcurrent device is connected. Failure to properly label the panel with the 88 volt output would violate this requirement. Given these concerns, the recommendation to use a single-phase panel for a 120/208 single-phase UPS output is a prudent one. A single-phase panel is designed specifically for single-phase power distribution and eliminates the potential complications and safety hazards associated with using a three-phase panel in this application. When it comes to EPO requirements, it's essential to understand the intent behind these requirements. An EPO system is designed to quickly and safely disconnect power to critical equipment in the event of an emergency, such as a fire, flood, or other hazardous condition. This allows personnel to safely evacuate the area and prevents further damage to equipment. The definition of an IT room in NEC 645.2 is quite specific, focusing on spaces with a high concentration of information technology equipment and a significant electrical power demand. This definition is intended to identify areas where a power outage could have a significant impact on business operations or critical infrastructure. However, it's important to recognize that the need for an EPO system may extend beyond these narrowly defined IT rooms. Any area that houses critical equipment, such as servers, data storage systems, telecommunications equipment, or industrial control systems, could benefit from an EPO system. The decision to install an EPO system should be based on a careful assessment of the risks and potential consequences of a power outage in a particular area. Factors to consider include the criticality of the equipment, the potential for damage or injury in the event of a power outage, and the time required to manually disconnect power to the equipment. Even if a space does not meet the strict definition of an IT room, it may still be prudent to install an EPO system as a precautionary measure. Erring on the side of caution can help to ensure the safety of personnel and protect valuable equipment. In addition to the NEC requirements, it's also important to consider any applicable local codes or regulations. Some jurisdictions may have more stringent requirements for EPO systems than the NEC. It's always best to consult with local authorities to ensure compliance with all applicable codes and regulations. Furthermore, the design and installation of an EPO system should be performed by qualified personnel who are familiar with the NEC and other applicable standards. The system should be properly tested and maintained to ensure that it operates reliably in the event of an emergency. In summary, the use of a three-phase panel for a single-phase UPS output is possible under certain conditions, but it requires careful consideration of the potential complications and safety hazards. A single-phase panel is generally the preferred option for single-phase power distribution. EPO systems are required in IT rooms as defined by the NEC, but they may also be beneficial in other areas that house critical equipment. Always consult with qualified personnel and local authorities to ensure compliance with all applicable codes and regulations. In situations where an 88-volt output is unavoidable on L2 when using a three-phase panel for single-phase UPS, implementing additional safety measures becomes even more critical. These measures should focus on preventing accidental connections to the 88-volt output and ensuring that any equipment connected to it is properly rated and protected. One important step is to use non-standard receptacles for the 88-volt output. This will physically prevent devices designed for 120 volts from being plugged into the 88-volt outlet. Several different types of non-standard receptacles are available, and the specific type used should be chosen to minimize the risk of accidental connections. The chosen receptacle should be clearly labeled with the voltage, and warning signs should be posted in the area to alert personnel to the presence of the non-standard voltage. Another important safety measure is to install overcurrent protection devices that are specifically rated for the 88-volt circuit. Standard 120-volt circuit breakers may not provide adequate protection for an 88-volt circuit, as they may not trip quickly enough in the event of an overcurrent. Using circuit breakers that are specifically designed for the lower voltage will ensure that the circuit is properly protected. In addition to these safety measures, it's also important to educate personnel about the hazards of the 88-volt output. Training should be provided to all employees who may come into contact with the electrical system, and they should be instructed on how to identify and avoid the 88-volt outlets. Training should also cover the proper procedures for connecting equipment to the electrical system and the importance of using only equipment that is rated for the correct voltage. Regular inspections of the electrical system should be conducted to ensure that all safety measures are in place and that the system is operating properly. Any deficiencies should be corrected immediately to prevent accidents. If possible, consider using an autotransformer to step up the 88 volts to 120 volts. This would eliminate the need for non-standard receptacles and reduce the risk of accidental connections. The autotransformer should be installed in a secure enclosure and properly grounded. The output of the autotransformer should be clearly labeled as 120 volts. Before implementing any changes to the electrical system, it's essential to consult with a qualified electrical engineer or contractor. They can help to assess the risks and develop a comprehensive safety plan. They can also ensure that all work is performed in accordance with the NEC and other applicable codes and regulations. Finally, keep detailed records of all work performed in the electrical system. This will help to ensure that the system is properly maintained and that any problems are identified and corrected quickly. The record should include the date of the work, the name of the person who performed the work, and a description of the work performed. Consider using a single-phase UPS with a 120/240 volt output if the load is compatible. This would eliminate the need for the 88-volt output and simplify the electrical system. The 120/240 volt output can be used to power both 120 volt and 240 volt equipment. This would eliminate the need for non-standard receptacles and reduce the risk of accidental connections. Ensure that the UPS is properly sized for the load. The UPS should be able to supply enough power to support the load during a power outage. The UPS should also be able to handle the inrush current of the load. Install a surge protector in the output of the UPS. This will help to protect the load from voltage spikes and surges. The surge protector should be rated for the voltage and current of the UPS output. Regularly test the UPS to ensure that it is operating properly. The UPS should be tested at least once a year. The test should include a full load test to ensure that the UPS can support the load during a power outage. Keep a spare UPS on hand in case of a failure. This will minimize downtime in the event of a UPS failure. The spare UPS should be the same model as the existing UPS. Follow all manufacturer's instructions for the installation, operation, and maintenance of the UPS. Failure to follow the manufacturer's instructions could void the warranty and create a safety hazard. When dealing with UPS systems and electrical panels, always prioritize safety and adhere to established codes and regulations. The NEC provides a comprehensive set of guidelines to ensure safe electrical installations. Consulting with qualified professionals and implementing appropriate safety measures will help to protect personnel and equipment from potential hazards.